다시 믿어 backpacker 우리는 backpackers yeah, we the backpackers 내가 묻은 신발이 바래줘도 backpacker 우리는 backpackers yeah, we the backpackers 제 가방 안에 굳은 다시 믿어 backpacker 우리는 backpackers yeah, we the backpackers 내가 묻은 신발이 바래줘도 backpacker 우리는 backpackers
We received a Class A emergency. The students are dehydrated.
Drinks are punishing faster than my allowance.
The situation is critical. Our road's not safe. Operation There's No More starts now.
What? No drinks?
I can't live without drinks.
My throat is dry, like my love life.
How many drinks do you order?
Only 50 bottles.
Does 50 bottles enough for all the students in school?
No, there are times when 120 students buy drinks.
We got what we need. Agent, is it here the date of yes? Yes.
Recover data for the crimes.
Okay.
Good day everyone, today I will be presenting our statistical analysis using the Pearson-Lard correlation coefficient, and our goal is to determine whether there is a significant relationship between the number of buyers and the temperature across 5 days. In this slide, table 2, here is our data for the week. We have recorded the number of buyers each day, along with the corresponding temperature in degrees Celsius. On Monday, 95 buyers at 32 degrees Celsius. Tuesday, 110 buyers at 34 degrees Celsius. Wednesday, 102 buyers at 33 degrees Celsius. On Thursday, 98 buyers at 31 degrees Celsius. And on Friday, 120 buyers at 35 degrees Celsius. We also computed the values needed for person R, the squares of x and y, and the product of x, y. The totals are shown at the bottom. In this third slide, to determine the strength of the relationship between buyers and temperature, we use the Pearson's formula. Substituting the values into the formula, we computed the numerator 295 and the denominator of square root of 12,40 times 50, and this given us a calculated R value of 0.923. In the slide 4, the decision rule. To determine whether this value is significant, we compared it to the tabulated R value and degrees of freedom. N minus 2 is 0.5, minus 2 equals positive 3, and a critical value is 0.878. Our calculated value is 0.923. Since 0.923 is greater than 0.878, we rejected the null hypothesis. In conclusion, is that there is a significant relationship between temperature and the number of buyers.
A strong correlation in an average demand of 105, the canteen must cut at least 110 drinks per day.
The data is clear, the temperature drives the drinks. Correlation exposed.
Case evidence complete.
Welcome to my TED Talk, the rise of how the statistical trinity now happening in the school of SPC. Now let's visualize the correlation of our team uncovered. It confirmed that as temperature increases, the demand for drinks spikes. Let's take a look at the Friday scorching hot. The line explodes at 120 students per day, while in the line graph, we can see these two curves, right? They are practically opposite, and this is what a strong positive correlation looks like. So let's move on to the pie chart. You will see the 70% shortage and 30% of satisfied. And because the canteen only stocks 50 drinks per day, the 70% students remain in their Ohio zone.
Using persons R, our team identified the true cause of the shortage. Temperature directly affects drink demand.
By analyzing the correlation, we determined the needed stock level to prevent future supply failures.
Match the demand in field graph and calculation. Our recommended stock level is 110 drinks per day.
That is how mathematics turned chaos into control.
We followed the math detective's recommendation. 110 drinks stock per day. And look, no more shortages. My soul is hydrated once again.
This is what happens when you listen to mathematics.
Versus our saved my world.
Correlation identified.
Shortage eliminated.
The data smoke.
And it leads us to the truth.
This mission was scrapped using real evidence, real math, and the power of correlation. By identifying the problem, to calculating persons R, to apply the solution, the math detectives have restored balance in the team. Case 1 closed. Math detectives signed off.